Hello, today I'm going to show you how I did it. This LED tube, which is audio reactive and rhythmic with all colors, connects to the internet and has a bunch of really cool modes. The first thing is to buy the cheapest LED tubes you can find and make sure they're made of glass. Obviously, well, they're all made of glass anyway, since that glass is painted on the inside with a coating that will diffuse the light. You'll see more about this later, but anyway, they're very cheap and the quality doesn't really matter. I bought the cheapest ones I could find and I think each one cost me less than $1. Just so you get an idea, you have to cut off the end. You'll see it has a metal end where the anchors to the tube's support are. And you cut it with a small saw. Very carefully, because if not, you could break the glass of the tube and, well, it would be ruined. Once you cut it, you'll see that on one of the ends there will be a small source. This source converts 220 volts to the 5 volts required to operate this tube. And no, I know you're asking, can we use this source to power the LED tubes we're going to replace it with? No, this one doesn't have enough capacity. Next we'll wire everything up. Actually, I'm going to leave you a diagram, since it's much easier to understand. We'll use WS2812 smart LED strips, the same ones used in my smart clock project, in case you saw it in another video. And there are very few components, as you can see the LED strip, a Wemos D, a mini, which will be the one in charge of controlling it, a capacitor for extra safety, and a 5V 3A power supply. The controller is simple, featuring a small microphone and a USB port. Also the same Wemos D1 model, not the exact same one. Use the microphone I'm showing and will leave in the description, as not all mics work. What if you're from Argentina? I'll leave you this page from my friends at Lutech, who are the ones that gave me the power supplies to make this video, so give them a hand and buy the power supplies from them. Cut the LED strip at 71 LEDs, so count 71 LEDs and then cut it. It's about 1 meter, 20 centimeters around there. Once you cut it, we're going to stick it onto a stick, which in this case is a metal stick, but it can be any thin and hard stick. We're going to remove the adhesive that comes directly on the LED strip. You see how one side is sticky? Well, on that side, we remove that sticky strip and we're going to stick it on upside down. So we're not going to stick it with that adhesive. Instead, we're going to hold it from both ends with a little strip. The iron rod has cotton stuck to its corners and is attached to the object. The reason for this will be revealed shortly. In addition to the factory adhesive on the LED strip, I applied some extra glue in a few spots for added security, although it's not strictly necessary. I later tried it without the glue and it didn't come off, so it's all good. Let's take the tube, which we have already cut both ends off, and very carefully insert the stick inside. Find the best way. I think that's how I ended up doing it, which I think was the best, and with a lot of... Here you'll see that the cotton is precisely so that the ends of the stick don't scratch the paint on the tube, because if you scratch the paint on the tube, you'll ruin it. Once you put it in, you stick the LED strip onto the other strip. Let's say inside the tube there's a factory installed LED strip. Well, you stick the new LED strip onto that one. And with a little pair of scissors, now you cut the tape that we used to attach it to the stick. I don't know if that makes sense, but anyway, that tape that was stuck to the tube. And like this, once we've done that, we remove the tube, making sure that the new LED strip stays inside, stuck on top of the old LED strip, and that's how it should look. What we basically did was replace the original LED strip with this other LED strip, which is smart and red, green, blue, and which is really nice. Let's say that's the only thing we got out of all this. Next, visit the link in the description to access my GitHub repository about this project. We go to where it says release and download the controller.bin, the Helios updater, and the LED bin. The updater is a program that I developed in Python, and now you'll see what it's for. We connect the controller or the tube via USB. It's the same, it doesn't matter which one goes first. Simultaneously, open the Helios update rexy program on the computer. This is a program that, as I already told you, I developed myself. And it will make it much easier for you to upload it to FineWire, whether it's from the tube or from the controller. So it's specifically made for this project and has all the preset configurations. So you don't have to know anything about the subject, nor do you have to worry about making mistakes. You just select where it says FineWire. Then, if you're uploading the one for the tube, you select LED bin, and as you can see, it generates a log that you can check. But anyway, it's more of a matter of preference for reporting errors and such. And well, first you do the thing. If you install the tube, you upload the tube's firmware, and then you disconnect the tube, connect the controller, and upload the controller bin. I don't know if that was clear, but anyway, that's how it's done. And don't worry about this program. Sometimes when you download it, it says it might be harmful to your computer. I don't know, but that's because it's a program I made myself and it's not signed. You can actually see the source code in the GitHub project to clear up any doubts. It's based on another open source project. What I did was give it a new look, let's say a new interface, and pre-configure everything. Connect the controller to any USB port, connect to the Helios bar network using the password TheHackLife, respecting uppercase and lowercase letters. As soon as you connect, you'll see this message, which is a little welcome message. And then you'll have to choose if you want to use your Helios. That's what I called it. The device works fine with or without internet, but using it with internet is recommended to unlock additional features. Some greater ease of use options. Anyway, if you want to use the internet, select your Wi-Fi network, enter the password, and hit connect. It will restart, reconnect to the network, and a HUB ID will appear. We'll talk more about that later, but anyway, everything is already set up there. Your tubes, and this will be like your app. Every time you want to configure your lights, you just connect to the network. This page will open and it will be like the app to configure everything. If you turn them off, you can also factory reset and set them up again. All over again. Now you can go to the Helios Bar website. If you chose to use it with the internet, you enter your hub identification there, the one we just talked about, and you'll have a completely web-based interface to control your tubes from wherever you are. That means you can control them even when you're not at home, since the tubes are connected to the internet and can be managed from anywhere in the world. Using the web app on a laptop is similar to the mobile app but more convenient as it allows for easier control. You can change everything, turn them on or off, or make adjustments whether at home or away. What we're going to talk about now is creating apps. Creating apps is a really great tool and all the documentation is on GitHub. I created a whole application programming interface to manage the tubes and simply in JavaScript or directly using the application programming interface from your favorite environment, simply perform a basic task. Script, let's say, you create your app if you know how to do it, if you have any programming knowledge, and it will generate a link for you. If you keep that link open, it will run your app over and over again. This is very useful, for example, if you're a streamer, you can set it up as a widget and hide it so it can't be seen. For example, you can set your tubes to change color or trigger an effect whenever someone subscribes to your channel or follows you. This is really cool and has a lot of uses that you can explore. I made a 3D base for the tube, but honestly, I kept it as basic as possible. I thought the base didn't need to stand out too much. As long as it's easy and simple, that's enough. Underneath, there's space for the Wemos and capacitor to fit. I didn't do anything to the controller, I just left it as it was because honestly, I thought it looked nice. But well, you can make a 3D case for it, or you can do anything you want, or you can simply do nothing at all. So how does this work? There's a controller that will connect to the internet. It will constantly be receiving and sending information to the internet. And it will connect to my server through a message queuing telemetry transport socket. This will keep the application programming interface live, allowing us to manage it through the application programming interface. I don't know how long this will be available since the application programming interface is experimental and, well, it also has bugs. But anyway, I'm developing it and I hope it stays up as long as possible. Also, you don't need to configure anything. Any tube you connect by plugging it in, the FineWire S will automatically connect to its controller. It will send signals to any controller it finds nearby and the controller will respond. Once it responds, it will already be integrated into your entire system of lights, let's say. Now, when we send something from the web tells the controller and the controller repeats it to everyone. The processing speed is fast enough to handle microphone input and send it to all the tubes in real time. The controller can now be inserted into any USB port, such as on a speaker, television, or any desired device. And that's it, everything is working. You just connect the tubes with the power source to the wall and you can control it. For example, right now I am controlling it with the integrated app on my phone, but I could easily control it with the computer or anything else. It has a lot of modes, a lot of things that I programmed and designed. You can experiment with solid colors, two colors, audio rhythm, flash, or rainbow. It has a lot of things. This video project makes me very happy as I've been working on it for a while and think it turned out really well. If you like it, leave a comment and a like, and I'll see you in the next video. Bye. Thank you.